we are in 1973. 1973, remember we had promised an answer to the ad hoc committee, and I left out in this long discussion, I left out the many meetings where the symbol committee and the code committee would report to the ad hoc committee, where there were many meetings along the way, you know, to share with the ad hoc committee, so they knew the progress, they knew the problems, they knew the issues, they knew the challenges, and they basically were totally supportive. And I might also add that along the way, millions of dollars were solicited and obtained from the entire industry in order to support the ongoing study, evaluation, and fact-finding. So it was a race. It was a race to the April deadline, and an intense debate with manufacturers. I mean, it got pretty intense. We had meetings with them individually. We would share non-proprietary data. We would answer their questions. We would take questions for other manufacturers, and we ultimately, somewhere in the March of 1973, I think the final meeting was in the Bank of America building in San Francisco, and it was hard to concentrate because of the magnificent views that we had from that conference room. But anyway, the decision. Now, what drove the decision? Here's what drove the decision, at least from my recollection. The first thing that was very important was the realization that when you're printing labels, you're printing it on a web press. A web press means that you have a big roll of paper at the beginning of the press, and then you go through the press and you have a big roll of paper at the end of the press, and so you're printing on a roll of paper. But because the press stretches the paper as it goes through the press, it actually distorts the web along the axis that it's traveling. It distorts it versus the direction across the web. Now, as you can easily imagine, if you're printing a bullseye, that means it's distorting part of the bullseye and not distorting another. And if you needed serious control of dimensions, that was going to be a big deal. Now, we also concluded that in order to accommodate the wide range of printing capability without forcing a solution that would cause small printers and label manufacturers and glass manufacturers to spend more than their fair share. Remember, they're getting no benefit. We concluded that it was very important to have an infinitely variable size symbol within boundaries. And we basically rejected the concept of various size symbols. And you can imagine that there were some that promoted the various size, and there was some that were prepared to deal with the variable size. And we felt that was exceedingly important. And I'll come back to somewhere here. I'm going to come back to, well, let me describe now. Having concluded that, the only symbol that was submitted was the IBM, what was called the delta distance symbology and encodation. Remember I said earlier that encodation was exceedingly important because that underpinned the accuracy of reading the symbol. And in the IBM symbology, there were 7 bits and 2 lines assigned for every character. But the way it's decoded is that they measure the distance from the leading edge of the first bar to the leading edge of the second bar, and you divide that by the distance from the trailing edge of the first bar to the trailing edge of the second bar. Now, for you math majors, you will immediately recognize that it does not require that you traverse those 2 bars in an orthogonal direction. You could traverse that bar in any direction as long as you, in effect, hit those 4 points, because it's a ratio decode. Now, there's another interesting phenomenon of the IBM symbology, and that is that if you produce the first half of the symbol as an oversized square, this is for you geometry majors, if you go through with a straight line laser, you go through any part of that oversized square, you will go through all of the bars in that oversized square and you won't miss any. Similarly, you can go in any direction across that. Now wait a minute, you're immediately going to say, well, okay, how are you ever going to read 10 digits if you only went through half the symbol? Well, let's just suppose that the encodation of the left side, that is the first 5 digits, was so-called positive or plus parity encodation. And what do I mean by that? Well, remember we have 7 bits, 2 lines, 24 possibilities. Of the 24 possibilities, there's 12 that are positive. What do I mean by positive? Well, if the first bar is 1 bar, 1 bit, and the second bar is 5, with a space in between, you have a even number 6. If, on the other hand, it was 1 and, let's say, 1 and 3, no, that's not right. If you have 1 and 5, it's even. If you have 1 and another one, you'd have a odd parity. And the symbol is constructed so that the first half is even parity or positive, even parity, and the second half is odd parity, which means that the laser can go through the first half and then travel around a bit and come back through the second half, and the computer program will, in effect, integrate the 2 sides of the symbol and give you the full 10-digit character. Plus, they will have measured the number system designator as well as the modulo check digit. So that's pretty important and bore directly on our decision. Now, I said variable. Given the fact that it's a ratio decode, if the symbol was accurately created in the first place, then in the printing process, as all of you know, you take a film of this symbol and you photographically use it in the printing process. It turns out that you can, if you photographically increase it, you are uniformly increasing it or uniformly decreasing it, you can therefore print a symbol that is infinitely variable. And we set the range, I think it was 0.8 to 1.2, so that, again, for a milk carton, for example, you could print a real big symbol, and for a, let's say, a drug product or health product, you could print it much smaller. And so that process was exceedingly important and led pretty much directly to the selection of the symbology. Now, it also led to another fundamental decision, and that is that if you produce the symbol very accurately on a film, and there's an industry that supports the packaging industry that produces images for printing, for any kind of printing. It's the label, it's the picture of the label, but it's a photographic image, digital image. It was exceedingly important that those film masters of symbols be held to extremely tight tolerances. And we met with the people that make those film masters, and concluded that the tolerance on those could be held as close as plus or minus 2/10 of a thousandth of a degree of an inch. 2/10 plus or minus. It might have been plus or minus 1. And they all agreed it could be done, and they all agreed that it could be done at a modest cost, and that they could charge as much as $20 for one. Remember that you only need one for a label, and therefore it wouldn't pose a significant burden on the industry. Well, we had a fireside discussion with these people, and we said, we get to basically certify each and every one of you as UPC symbol film makers. And we want you to understand that our program success relies on the accuracy. We don't want anybody cutting corners. And for that matter, we don't want anybody cutting costs. And so we hope you'll understand that that paramount in our implementation program will be to certify and to decertify symbol filmmakers that don't meet the accuracy requirements that we've specified. That allowed us to do one other thing of great importance, and that is to eliminate any and all dimensions on the printed symbol. There are none. There's nothing to inspect. You can inspect to see whether or not they met the line edge irregularity or the void content, but there are no dimensional tolerances. We envision thousands of people being hired to measure symbols in the industry and accept or reject product from manufacturers. But since there's nothing to inspect, those 1,000 people didn't get the job. And that was a very important part of our basic decision. At the last minute, there was another problem that cropped up, and that is I think it was the FDA was quite concerned that a checker who was constantly looking at the laser light coming out of the scanner, that it might damage their eyes. And so we went around and around with some of the great medical minds at the time, and there was a decision made that if the power were reduced to a certain level, not to exceed a certain level, that the damage, the potential damage to anyone was not a big problem. And so all the manufacturers understood, all the laser scanner manufacturers understood they could not exceed that. And I think that ended up in one of the manuals that was used. Now, we finally got together in very early April, late March of '73. Met with the symbol committee, recommended its selection. In this case, they recommended the IBM symbol. IBM had acquiesced to our demand that it be put in the public domain, which they did. And so all the conditions were met, and the ad hoc committee agreed with the recommendation. It was a unanimous recommendation by the symbol committee to select the IBM Delta Distance code. We had hoped that many of the equipment manufacturers, knowing that IBM did not have a patent advantage, would jump in and produce scanners. Many did, some did not, and notably RCA did not, for reasons we never quite understood, but anyway, they dropped out. It was announced at the McKinsey headquarters in New York somewhere around the 2nd or 3rd of April 1973. I thought it was April 1st, but apparently not. And it was, and we were off and running. The first store was a Marsh store a year or so later, and the rest is history. I mean, it's now the ubiquitous method for handling the checkout process. And I might add also that it became obvious that the retail industry, unlike or just like it had always done, has effectively passed on the productivity savings to the consumer. And the only fight that ensued after that was the retail clerks union sought to prohibit the removal of prices from consumer packages, and that fight went on for months and so forth, and ultimately there was an accommodation and they gave up on that fight. And I think that basically there were a few other little skirmishes, but that was about it. Now, the other thing that happened about this time is that the symbol advisory, the ad hoc committee recommended to D&B, or whoever was going to manage it was D&B, the issuance of the code numbers. They would also issue the symbol specifications, the location guidelines, and so forth. The symbol committee recommended the formation of a technical committee, the Symbol Technical Advisory Committee, which was in fact formed and proved invaluable over the next few years, helping people over implementation problems and so forth. That turned out to be an extraordinarily good idea. At this point, Russell went on to other clients and ultimately now is retired, living here in part of the year in Florida and the other part back up in Chicago. Tom Wilson stayed on the effort for a very long time, offering his counsel, and that's about all I know. about this program.